Hello and welcome to one more live stream for stay.coti.io. I'm Percival Lucina, I'm your host for today, and I'm have here with me my fellow engineers, Rafa and Davi. Rafa, do you have a few words to say to our audience?
Hi, Percival. Yeah, so excited to have this live stream about this topic with data privacy stuff, and it's great. We're gonna learn a lot. So thank you, Percival.
Thanks for being here, Rafa. And we also have the awesome Davi with us. Davi.
Yeah, thanks, Percival. Yeah, very excited to this topic today. Very interesting topic to cover. So that's it. Let's go.
Okay, so I'm gonna share with you now the roadmap for today. We plan to create the app from scratch. There are lots of things to do to create the app. So I'm here to show some of the tools and some of the process. We plan to recreate a private ticket in the app using the data privacy framework, which is a tool that the COTI team has prepared, a set of smart contracts to set up privacy. So let me share the screen and start sharing some thoughts with you guys. Okay, so I'm sharing my GitHub here. Now let me try to change a little bit uh, the workflow here so we are able to see the whole screen. Um, I think that's better now. Okay. Hey Robert, thanks for joining.
Hi
Okay.
guys.
Hi again. So I have created a repository with all the steps you need to use the data privacy framework. The data privacy framework is a set of smart contracts developed by the COTI team that allows you to basically define permissions for different kind of users and the actions they can do on a D app. That's quite similar to what we have when you use some normal Ethereum frameworks like OpenZeppelin, right? When you're gonna create a new ERC20 token or an NFT, instead of starting everything from scratch, you start by extending one of those OpenZeppelin contracts, right? So you get the basic functions, right? And the same thing would apply for us here when we are developing some COTI projects. So if you want to do things like defining access control or selecting disclosure, what kind of people can see specific information, instead of you having to define the logic of all those things, you can extend those data privacy framework smart contracts. And based on that, uh, you can define which kind of users would have a different set of roles. For instance, during my presentation here, we're gonna try to recreate a ticket, private ticket information. The app, it's a kind of application where the user would be able to buy tickets, but there would be other special type of people who are the event creators who would be able to create events on the platform and sell tickets for those kind of events, right? So there are those two different kind of users for this application, like the admins who are able to create events, and we also have the normal users who just want to buy tickets and make sure those tickets would uh, be on their platform. And we are also extending privacy here. When we have this kind of DApp on the COTI network, we can make many things that would be public on chain private, like the price of the ticket, who owns the ticket, right? All those kind. And even if you're gonna resell a ticket, you want to make private thing like people might not say how much you paid for the ticket, right? You might want to keep the price private as well. So we also want to not only set permissions as we have on other networks, but also explore COTI privacy features in this D app. So our plan to do that is to create things in a specific structured way. Using different tools, so we can develop this whole application from scratch. So our flow here, we're going to start developing the Solidity smart contract using Claude 4. We're going to use some specific templates using Visual Studio and also GitHub Copilot. So we start by defining the smart contract we want to create. And after creating this smart contract, we're going to create an ethers client that will interact with this smart contract and test all the applications. So instead of jumping directly to building the app and the UI, we're going to create this console or text-based client, and it will be reused as the base of the functions to create the UI. So this step is very important, creating the client, because it allows us to deploy the smart contract, test all the functions, and the code that's generated, it's also used for the UI application, so it learns how to interact with the smart contract. Okay, so that's the plan for today. Lots of things to cover. So I'm going to give you a quick introduction about what is the data privacy framework. There's lots of documentation about it. It would be kind of boring if I cover everything here, but just for you to get a quick overview of what the data privacy framework is. So the data privacy framework is one of the contracts that are available on the smart contracts on the CodeSting GitHub. And it basically creates some structures which are input datas and also permissions that allows you to specify things like which address the rule apply to, what kind of operations you're going to create on your smart contract, when this rule is active, when this rule will expire, um, and also some other parameters like force and the rule to be applied on some specific conditions. You don't have to worry much about all those parameters, because here on GitHub, I also provide you some examples of some specific permissions that we want to create for this application. For instance, we might want to admins to be able to create an event like a concert or some specific event we want to sell the tickets, and then we might want to specify a time frame where this event is active, and this can be set by a rule here. We can also want to create specific rules for disable access to some specific function we define in our smart contract, and many other things that we want to think during while we develop the whole application, right? Instead of going through all this documentation here that's available on GitHub for everyone who wants to follow, I'm start moving to VS Code and start showing the process of how we create a smart contract using the data privacy framework, right? Okay, let me jump to Visual Studio Code here. So today I'm gonna use GitHub Copilot using Claude Sonnet 4 to develop our smart contract and also the client that interacts with the smart contracts. And one of the things we have with GitHub Copilot is that whenever we want to do something different, like working with code ethers, instead of trying to add all this information in prompts as contexts, it now allows us to create what they call instructions. Instructions, I think Upendra showed on a previous live stream something very similar that's available on Cursor, that is the context. The instructions is basically a shared context that the application uses for all the prompts that you generate, right? So it's a set of rules that we define. So when we run our prompts, it will consider this as part of the context, right? So I created here, and the thing about these instructions is that they are available here on the uh, GitHub Copilot, and they are usually stored on a separate file. And you don't need to specify that file because on the settings for the GitHub Copilot, it always will check those instructions before running the prompts. So what have I set here on those instructions? I have set some basic things we use on every time you create a COTI smart contract, like the version of the Solidity we want to use. We want to connect to the COTI network. For the backend, the kind of stack you're gonna use here. For the client libraries that we're gonna use the COTI ethers that's included in part of our GitHub here. So instead of using the standard ethers library, we're gonna use the code ethers to build our client. Hard hat to deploy our contracts. Some specific formats. One also important thing that we define here in the prompts is that we're going to use the MPC library and the MPC types for keeping the data private in our event ticketing. So we're going to choose that things like the ticket owner and the price to be kept private, and it basically gives us some things. It also provides some examples about how to import libraries, that our smart contracts should extend the data privacy framework. We need all this kind of instructions to make sure that our prompts will converge or will execute right, with fewer interactions, right? And when we are using AI tools to build smart contracts, or when we are using AI tools to build clients, UI, the apps, you always need to provide this kind of instructions. If you don't do that, it will take many prompts. You're gonna need to run your prompt several times in order to accomplish your goals. So you need to plan that before creating the smart contract. And the smart contract we want to create is something that was available on the COTI website. Let me just open the README file here again. Okay. The smart contract we want to create is here. It's a single file COTI smart contract that extends the data privacy framework for creating a ticketing smart contract. And the ticketing smart contract should ensure that privacy is preserved. It might define some objects like ticket, events, ticket ownership, and those smart contracts should use MPC data types for private information. And I also added some instructions here about how to use those MPC data types on the smart contracts. The contract should allow users to purchase and store events tickets digitally. The ticket should be tied to a user address, right? And implement MPC for privacy allows users to prove the ticket ownership without revealing personal information. Smart contracts should be able to transfer tickets and enforce resale policies, ensuring fair pricing and reducing fraud. So the admin can set a margin about how much profit the tickets can be resold. So that's the kind of smart contract we want to create. And the smart contract would be based on a sample example that's created by the COTI team that's called on-chain database. The on-chain database is basically just a simple class that extends the data privacy framework for a simple and provides some examples on how to use that data privacy framework to set permissions and retrieve items and delete items. So that's the basically smart contract we want to do now. There's many of the details about how the ticketing system works that are not specified on my prompt. And while the prompt runs, it will try to generate that for you, the kind of information. Fill up the details. Okay. So let's see how it goes. So I'm gonna just copy the prompt here, make sure I'm gonna add the necessary files as context. So I need to include the data privacy framework. Hold on. As a context, I'm also needed to include the on-chain database as a context. The MPC core, which is the base core contract for all the privacy on the COTI network. And also the MPC interface. I provide all these files on my GitHub, and they are organized here so we can start generating the contract. So let's go. Let's see how it goes. So GitHub Copilot is running. It's creating the private ticketing based on the prompt informations we asked. So since we left many of the things open, right, it might decide different way what kind of things are private and what kind of things are not private, right? Because we didn't specify on our prompt exactly what kind of information we want to keep private and all the other information we don't, right? So let's see how it figures out.
Should it deduce that from the examples you uploaded?
Yes, it knows how to keep things private, but I didn't specify what kind of fields I want to keep private, right? So here it says that's using the cipher test for ticket prices, for seat numbers, user balance, and ticket values. That's what he decides to keep private. I didn't inform it what kind of information I wanted private. So it decides that it has decided that the ticket prices, seat numbers, user balances, and values would be kept private. Users only can decrypt their own data. There would be the event management for the admins, right? And that use the data privacy framework to, so only admins would be able to create new events, ticket operations, and as anti-fraud, it creates that kind of ownership verification and transfer limits. So it says the contract follows the best practices, never storing garbage tested in storage, and using cipher test. Those are the MPC data types. Okay. So here it goes. It has created the private ticketing smart contract. It has created one structure called event. And well, I don't see it here using COTI, add COTI types. No, yeah, here for the mapping, it uses for the mapping, right? So although the structures are public, those kind of structures it created are public. It uses mapping, and on those mappings that are lists, right? The lists, the list structures that stores this data. These lists are private, so the ticket prices are private, and the seats are private, and other things are also kept private. Just to compare you, every time you run the prompt, it generates this smart contract logic a little bit different. The last time I have run the prompt, instead of keeping the types private only on the lists, it has created me a different structure where it has chosen to keep the events, the information on the main object private. Well, those two things are acceptable. You might want to keep the object data private. That's the most logic thing to do, or the simplest thing to do. But it looks like this other solution it created now of keeping the private things on the collections are also good as well. Okay, it has created a smart contract for us, for our ticketing system, right? That has all these basic things. It has event, it has tickets, right? It has some functions, right? One to use the data privacy framework, to set some specific permissions. It has created a function to create an event, a function to check the permissions, a function to debug the permissions, a function to purchase the ticket, a function to get the tickets for a specific user, and a function to prove ownership, a function to get the ticket price. So everything that we need for that kind of the app, the logic for the smart contract was created here. All of this logic that it has created works or not, right? We needed to create a client now that would be a kind of program that you're going to use code ethers. It will create some test examples for us, and it will try to execute the logic of purchasing tickets, creating events, and everything. Let me show you this logic running, and then we're going to recreate this client from scratch. Okay, in order to get what we want to do now is to create the client. I'm gonna run the client that I already had created beforehand, but we're gonna recreate this client as well using GitHub Copilot. So the client is running now. It has connected to the COTI network. It has retrieved the my wallet funds. It is deploying a new smart contract on the COTI network, right? Here's the address where this contract is deployed. I'm gonna check that in a second. And it's gonna do some tests for me to test my smart contract. It's gonna create a new event. It's setting the permissions for a specific for only my address being able to create events. I can add other addresses, admins as well. It's getting information for the event it created on the smart contract. It's purchasing a ticket. So it's checking the purchase, the ownership of that ticket, getting the encrypted price for the ticket. You see the ticket here it's encrypted, right? It's not that the real price of the ticket. And it's creating a second account to transfer the ticket to another person that I just bought to make sure that the ticket transfer works. So this kind of client that we want to create here, it basically validates that our smart contract works well. And we're going to provide this client for Replit, which is our UI tool. So it would be able to use as the basis to create this application, right? We're going to test that in a second as well. Okay, so let's try to create a prompt to create this ticket based on the smart contract we just generated here, the private ticketing smart contract. It probably won't run well the first time. It might require 2 or 3 tries until it works, but let's see how it goes. So I have also created a prompt here to create this client to test my smart contract. So in this prompt, I tell every information that's needed. Unfortunately, we needed to tell our private key, right? Because it needs that information to connect to code. Instead of setting this in the prompt, you can set that information on an environment file if you think it's a better practice. But in order to make sure that the prompt works well, we're gonna add this here. So what do I need to add to create this client? I need to add the COTI ethers library, right? So even though I specified that in the instructions, I'm just making sure that it's using the COTI ethers to create this client. And the cool thing about COTI ethers is that it also is useful to create the app on the browser. So it's always a good choice. So I am adding the COTI ethers here, and of course I need to add the smart contract I just created. So this is the latest version of the smart contract that was created. So let's see how it goes. So I added all the information I needed here. So I'm gonna run the prompts now to let me remove this. It's not part of the prompt. In our last live stream, Upendra did something very similar. He also created a text-based smart client to test his smart contract. The only difference here is that we're gonna try to go one step further and use this client to create the app. And when we do that, there is other things we need also to cover. Okay. It's asking me to run to copy some private ticket into this folder, and I say it's okay. I'm running on agent mode, right? So he's doing all the interactions on the agent by itself. I just needed to.
So hands off.
Yeah, hands off. So it's trying to compile the smart contract, right? So far we only had created the Solidity, and that's one of the things that's harder for creating the apps, right? When we are doing things like creating tokens or other things, right? We also have the Davi's new service that allows you to do that automatically. But when you are creating the app, you always need to specify your smart contract, right? The tools help you to do so, but you always need to create the smart contract. So looks like it has it was able to compile the smart contract. No. It says it might have some problems while compiling the smart contract. Let's see. And it's creating the private ticketing client class. This private ticketing client class is a TypeScript class that interacts with all the functions that are defined on the ABI smart contract, right? So this is the core code that we need to create that beautiful the logic to interact with the all the functions that are defined on the smart contract, right? And that's what it's trying to do now. It's trying to create the private ticketing class. It's creating a deployment script. You saw that when I run my client, one of the things it does is it deploys the smart contract on the COTI network for yourself. And that's one thing good because for using the data privacy framework, deploying it by hard hat, it really helps to make the process really simpler. So it created a script to deploy my smart contract, this new smart contract we just created, right? And now it's going to create the demo script. The demo script is the one that we just run that is the script that executes all the functions from the client and validates the logic.
So the demo script is simulating a sale, basically.
Yes, it simulates a sale, it simulates a transfer, it simulates create events, all the functions that we have on the. In fact, it executes those functions, right? It's like a test script. And it's also creating some documentation for us. All right.
Nice, a professional AI. So, did you purchase like a pro plan, or are you using the free plan for those?
I'm using the Pro plan for GitHub. I also I used like a 3 month trial. It expired a couple of days ago.
Mm.
But using Sonnet 4 is something that's really worth, right? It costs $10, and
Oh,
it's so awesome, right? It's like half price of Cursor.
yeah.
Okay, now I need to keep the files. Now it's gonna try to run the client the first time. So I think that approach is very important, right? Before you start building your DApp UI code, create a client like this to make sure that didn't find the COTI ethers, try to install the COTI ethers. We really didn't validate the contract it was created until now. So now it's trying to interact with the contract that we created, right? We didn't really go deep into trying to understand if the contract we created was good or not. So it's learning how to deal with the privacy data types from the contract. And we expect these private data types it's using are right. Yes, CTU int 64. Yes, it's the same. Yes, it's using the right data types. And while the client is being created, it might change the logic of the smart contract so it compiles right and to do the logic it should do. So creating a DApp might be something that doesn't work completely right the first time. So it's common uh, going through all this checking until you have the client working beautiful, as I showed you. So the client's still not fine, still have an issue with COTI ethers. Let's see if it's able to figure out by itself. Seems like the data types that were being used were somehow not properly imported. One of the things that I added here on my GitHub Copilot instructions, and I also give the instructions, is that I provide some examples on how to store private data and retrieve private data. So I hope it's using those kind of examples to handle the private data fine. It's redeploying the smart contract. Or at least it's fixing the deploy script for the smart contract. It's rebuilding. Yeah, I don't like when it tries to simplify things.
Yeah.
Sometimes it just removes the privacy from the demo. But
In your experience, GitHub Copilot's a good AI?
well, I built the whole application using GitHub Copilot. Let me see why it's not asking MetaMask here. What do you think, Rafa? What are your preferences?
Well, in my experience, literally like the last week I purchased cloud. Did you see like the cloud is in trending topic with cloud for version, and I choose it to pay the pro plan. It's $20 per month. It's not bad at all, but it's great actually. In this case, instead agent AI, I am using actually the terminal, and with the terminal you can also tag the files exactly as the same as agent AI, as this one, as a chat, or as a cursor chat. It works like that. It's cool. It's cool. The thing is that sometimes uh, when you exceed the tokens, even when you are in the pro plan, it pauses like for 2 hours or like 3 hours. It
Whoa.
blocked you for through. Yeah. But when you exceed the limit of tokens, even with you with Pro Planet, but like it's great. I'm just trying it.
Is it something similar to those kinds of the prompts AIs I was testing here on the terminals as well? I was testing the Gemini terminal here, and it was not as efficient as running Claude here. I tried to run the same smart contracts using the
Mm.
Gemini here, using instead of using the agent mode, using the terminal, and it kept the privacy out of. It was having some problems compiling my my smart
Got
contract,
it.
but that's
Got it.
cool. It's amazing that those tools are being each day they're being more efficient, right? Because we are asking more and more and more for those tools, right? We are asking them to do all the
Yes.
work. Now we're just watching.
It is.
So yes,
It
it
is.
looks like it's doing some progress here, right? It's the basic client is running, right? And it's able to deploy the smart contract. So it's not completely ready, but it's making some progress.
Life will find a way, what they would say.
Life will find a way. Very good.
It's going so speed, so quickly.
Well, it didn't let me check the M file to see the address that this contract was deployed, right? So it didn't really update the address here on the. So it was able to deploy the contract, or at least it says it was deployed the contracts. Let me ask you to run the full demo, please. Involving a ticket purchase. Well, now it's deploying. You can see the.
And if you're not on a pro plan, would it count these fixes as separate instructions as well, or is it included in the whole iteration?
I think, correct me if I'm wrong, but I do think those are separate instructions, right? So it get more and more of your tokens. So that's here, that's okay. The contract has been deployed, but there's still no invokings to this contract, right? It's not invoking it's not buying tickets or creating tickets or other things. So now it says gonna run the demo. Let's see. Well, errors, as expected. So it now is gonna try to fix the client so it executes successfully all those things like creating events and buying tickets and selling tickets and all the other stuff. Whenever that client is okay, we're gonna use that client as a basis to try to recreate the UI on Replit.
Yeah. And do we know what is the issue?
Yes, let's see. Here says there's an issue on how we are formatting the encrypting data for the contract call. Although I provide some examples here on how it should do those kind of encryption and decryption functions. It looks like when it created the code, it didn't follow all those instructions. So when it tries to invocate methods using private data, since everything is private, right? It runs into some issues.
So it means that it's calling the mapping, or actually the mapping's values, right? Because the functions, there is not like a private structs or private types, as I see.
Yes, here only the mapping is private in this version, right? In this version, only the private is mapping. And the last time I run the client, the smart contract, it created a different version with the private types on the main struct, not on the mapping. You see, the mappings were public and the data types were private, and now it's choose to do the other thing. So I don't know how much extra
Mm.
effort it needs to get to this different version running. So I really don't know how if it will converge or it will converge fast or not, because it's doing something different this time.
It's always doing something different as you expected, right? That's the issue
Yes.
with it, a little bit with the prompts and all that kind of stuff with AI.
Yes, and this shows a little bit of the reality of creating those clients on or the apps on using the existing tools so far, right? It shows that it probably won't run all well the first time you run the prompt. So I thought it was thoughtful to show everyone the real process behind the curtains.
Hmm.
Yeah, but luckily for that, we're getting better and better examples and continuously improve documentation to feed it. So should hopefully help out.
Yes.
Yeah.
Actually, not hopefully. I'm confident it's going to be better and better. Yeah.
Yes, and we need to learn how to use that tools, right? Every day the tools improve and include the new things here, like adding extra informations as instructions, prompt files, everything. So the more data you provide, the larger the chance you have of converging that in less interactions, right? It will eventually get it right, but it's still struggling to deal with the private data types that were included in the contract. it was able to execute the transactions, but the transaction reverted, right? You see here that it was able to invoke, right? It's trying to do some things like trying to create an event. It was able to execute the transaction, but the transaction revoked basically because some parameter or something thing was sent wrong. So when you see the client running, as I showed you, it seems all nice and fine, but there's some patience until you get to that point.
By the way, we can like use private types into events. In this case, for example.
That's a good question. That's a good question. The event can I do think so, Rafa, but I'm not
Yeah.
sure if there is any kind of event here that's using private data types. Let me check the events it exports in the smart contract. Need to go
Yeah,
back
but I
to
think because it's like uh, basically a tuple or like a bytes, and
yeah.
that's it. They'll just like encoded value. It's not something else.
Yeah, I think at the end
Looks
of
like
the day, it converts to native data types, because at the end, I mean, those private types, it's like structs, right? But they mapped to native types, Solidity types. We are just like wrapping them into a single structure, but they are native types at the end. So I think so. I think we can use it like in events as well. Of course, we need to decrypt it and also, I mean, handle those values differently. But you can see the value on blockchain in the same way.
Yeah,
yes,
exactly.
and the client needs to learn how to do this, right? How to decrypt.
Yeah.
Yeah, but if it's encrypted, it means that only one account can decrypt that value. So it's like, all
Yeah.
right, cool. I can drop some events, but only one person is able uh, to decrypt that value.
Yes, and this is one of the issues I had with the application as it is. Let me try to show you some things like here. Like when I create an event, let's say,
Mm, okay.
only the admin can decrypt the event, right? Although the transfer works for different wallets.
I was wondering about, could you delegate read access, for instance, for one of these values?
Yes, I think there is a function, right, Davi, to do that on the MPC library to delegate the.
Yeah, you can re-encrypt it to another wallet, but it's like on-chain action, right? So once you have the event emitted, I mean, let's say you can decrypt it, but if you want that other person be able to see it, you need to re-encrypt it, like to call again the contract to emit a new event, right? Because it was like encrypted. There is no way to, unless you share your encryption key with other person. Otherwise, you need to re-encrypt the message to have a new signature.
So I have created here an event using my account 8 here. using the app that I already had deployed, right? Let me see if I can invoke the. Yeah, that's the point I wanted also to point in this live stream. Although I'm interacting with the MetaMask here, right? Since I'm calling a private function, the client code needs to keep a version of of my ASCII server side. So one of the things that this client is generating is it generates based on my public key. It generates a function to retrieve my ASCII. So when I interact with the web app, part of this interaction, it's not using my real wallet here, but it's using the wallet the client creates on server side. So Rafa, whenever we have the AS keys on the snap function, our client would be simpler. It wouldn't need to keep a wallet on the server side to do this kind of transaction.
Yes,
So
exactly.
yes, it interacts with MetaMask, but it still needs the client still needs to generate a wallet on the server side to do all this stuff. Okay, let's see how our client is continuing. If it doesn't go like in 5 minutes, we can try to interact with the UI. So here it says it's testing all the functions of the smart contract, right? Create event, deactivate event, but not all those functions are working yet. Very interesting. It looks like it's going to a dark zone, right? It's not making progress.
Could you have it reiterate from a previous point where you saved the version?
Yes. He will try to, the tool try to redeploy the contract. Oh my. Yeah, you see the deployment always works right? The contracts are really, this part of interacting with hard hat, the tool knows how to do it very well, to compile the smart contract and deploy the smart contract. The part of creating the client is the most tricky one, because it has to do all this kind of logic of interacting with private data types and the data privacy framework. Okay, I'm gonna try to run the demo again. Good luck.
Good luck. Yeah.
Yeah, it basically says that it failed, that it wasn't able to generate the client again. So I'm gonna move to the UI part using the client I already had created beforehand, and let's see how the UI works. So people have the feeling about the struggles we have to create this UI, right? Because here, using that client that was working, I was able to create this UI, but you're gonna see that creating this UI can also be a little bit tricky. So I'm trying to recreate now the UI using the working client using the prompts I have prepared here. So for the UI, I also needed to tell things about like where the contract was deployed, the private keys to interact with, because it can't rely on MetaMask for doing all the things yet. I'm also needed to provide some files for example. Let's see what kind of files I need to provide. So I need to provide the TS client and the code ethers. Okay, let's try to grab those files from the. So this is the working logic of the client. This is a contract that really works. So I'm gonna try to provide him a work client here. And it really requires to go to. Okay, so let me go to the working TypeScript client. This will probably have all the logic it needs to interact with the smart contract, but I'm also gonna provide a working version of COTI ethers for the app. So I have the COTI ethers on build COTI ethers. Okay. And where is my building code? If I don't provide a code ethers for Replit, it's probably gonna get lost trying to use only the ethers, the standard ethers, and you're gonna fail. So let's make sure that I have a valid build code ethers here. Okay, I'm gonna grab from somewhere. Let's go to plan B. I don't have it in my workspace here, so I do have it in another project that I just created. So. Well, it's not finding the COTI. For some reason, it's not using the COTI ethers. So let's grab a chance. Let's see how it's gonna try to create the app with the information I provide here. I'm making the application life harder by not providing the COTI ethers for the app. You're gonna probably see that the UI itself is gonna work really well. The problem is always connecting the client code to the UI. So it's basically examining the client that exposes all the functions. And you see it's the same prompt and it might create a different UI. Let's see. Let's compare it, the UI I have first created. Since I'm not providing any kind of Figma or visual instruction, it might do a little bit different this time.
Sometimes they add flavor. The logic might be the same, but it's okay. Today we feel like this, and it adds another color or another scheme or font. Yeah.
And you see that everything it's doing so far, it's not really connecting to the real client, right? It's using fake data. And one cool thing I like here, Rafa, is that now you are able to see the transactions here of purchasing
Yeah,
things on MetaMask.
yeah. The thing about MetaMask Snap is that you can retrieve once you onboard it as well, absolutely, and you install the Snap into MetaMask. You can retrieve the AES key to your dApp and use it to decrypt any value you have there. And so yeah, about like the app I built, I am retrieving the AES key. I'm decrypting actually the values and the images from the private NFTs, right? So that's how it wanna works, and it's great because any DApp or any dApp or any backend as well, and everything just should call to the Snap, and that's it. You got it. But of course, you need to onboard. You need to install the Snap.
Yes, this version doesn't have the snap yet, so it probably shows everything that's encrypted. It shows the encrypted value, not the decrypted value of the ticket prices and all the things, but the method calls themselves are show here, even when you don't have the snap installed.
Yeah.
So it is still a lengthy process, right, to create a whole app from the scratch, right? Creating the smart code, the client, the UI. It's a process that usually takes more than an hour.
Yeah. Imagine without AI, yeah? Huh? Like
Yeah, imagine you
three
had to do this
hours.
by hand, Rafa.
Yeah, exactly. I probably will take a template or a boilerplate or something like that.
Definitely, definitely.
Oh, you started in Notepad in the 90s from scratch.
Imagine that.
Those were my
Yeah,
first ones.
But it's impressive how far you can go in 1 hour with AI. So a lot of things was created, a lot of code, and I mean, it will take, I mean, much more time doing it by hand.
Mm. So how was?
Yes, and I like this.
Yeah, go ahead. Sorry, Percival.
No, sorry, Rafa. Sorry.
No, I will. I want to ask you, Percival, how was in the 90s or to build like a full dApp like this or a full app actually?
Yeah, productivity was very low, right? People took lots of time to deliver the platforms. Lots of people working uh, to get things accomplished, like of backend developers, front end developers, working weeks and months and planning every function. Would be a new release that would take at least a week to deploy. So, and we also had to provide the environments because the environments were not in the cloud. Well, and this is one good thing about Replit I liked, right? Because you develop the UI here and you also deploy the server in a single tool, right? So you don't need to, at least for a development environment, you don't need to worry with infrastructure. It provides everything for you in a single place.
Yeah, here you can deploy it and you can publish to internet actually, right? And you,
Yes, and can even add a
mm,
DNS for that.
yeah,
So you can add your own domain on top.
exactly. That's a good one.
Yeah, it's really nice how they've been trying
So
to like cover the whole, let's say, development life cycle to get it to market. And now they're inserting like additions, as in security checks and other components of that, let's say, to continuously upgrade it. Yeah. You see that in the other applications as well, like in Lovable. It's really nice to see.
yes, and it adds some tests for your application, right? So it covers the major functions of your code, make sure that at least for the standard cases they behave well, not like and you can even integrate some security checks on that. That's one thing that some specific smart contract development tools that are using AI are also doing. Besides creating the smart contract, it also adds some audit and some other checks to make sure your smart contract is secure. What surprised me is I'm curious to check the. Okay, so all this information it's asking me to provide as here as environment variables, right? The contract address, the COTI RPC URL, all those things. It won't store on code, so I need to get there and grab that information. Even though I provided that on prompt. So it's basically creating an environment file for me for storing that information. Just let me check and open the right information, the private key. Always checking if I'm copying the right information. The contract address. You see this the right contract address. It has lots of successful transactions that were being executed during the tests. So it was deployed and then it was successfully executed as well. Okay, so the contract address. And also my AES key, which I'm not sure I provided. Oh, I provided here. You see here that it's the version it's creating it. I'm just checking the balance here. It's already connecting to COTI and retrieving my balance, right? So I'm not sure if the app client's fully working now, as this version we have here deployed, but the first version it created, it was able to connect to COTI testnet and connect this with my address and retrieve my balance. So let's see how it's working. It asked me to test.
But this was without giving it COTI ethers as input, right?
Yeah.
So we can assume this would be the unencrypted data, which is it's receiving right now for the balances.
Yes. I probably now the create event and the other functions. Not really sure if it's gonna work now because it's not. It's using probably standard ethers, but either way. One thing that's cool is that it's exactly the same prompt I used before, and you see that the UI it created, it was really different. It was the same client, the same smart contract. I just, the only difference is I didn't provide the code heaters because I didn't find it easily. So make sure I'm gonna update the GitHub instructions to include the code heaters on the right folder. But let's see if I'm able to create an event and invoke the smart contract. So the UI is always working right. The problem is invoking the. You see the logic. It's basically the same from as it created before, right? So no here on create event. You see, although the UI is different, yeah, the logic looks very similar. How much I can define as a markup percentage allowed. If I want to allow resale or not for the ticket. Yeah, and as expected, the first version of the the code didn't work. So how gonna proceed when something like this happen? gonna just get the error message and provide this error message to Replit so it can fix it. Or at least it can try to fix it. Oh, too late. Now it says the event was created successfully.
Lol.
There's a code live screen here, and we need to go to the smart contract to see there was any kind of invocation in the last seconds. The last time the smart contract was invocated was like 26 minutes ago. Yeah. Whoa. Do you believe in miracle, guys?
Oh my god. The third call was
Praise.
successful.
Wow.
Yep.
Yeah.
Well, yes, even on providing the code ethers library, I don't know how it's coding. I'm event is a method that doesn't have any kind of privacy enabled because the if you go to the code for the smart contract, right?
It would mean it doesn't use that mapping in that processor.
And yeah, let's go here. No, because we can see the smart contract here deployed, and it's really you can even compare the bytecode of the smart contract, and the one that's deployed here is really using the privacy feature. What surprises me is the new UI we just created, being able to, which of course is using a completely different AI. I don't have control what kind of AI Replit is using to create the client. I just provided the client as it is, right? And it's trying to a working client for it, right? And it's able to invoke the functions. And we can check the event smart contract here. It's on the smart contract folders, Solidity folders here. That's the version we have deployed. And you see here that the events, the price and the total supply and the ticket sold, they are all encrypted, right? So what we need to double check is if the price that it's using is the right price, right? Because I'm seeing here the encrypted price, right? So we did need to add an extra function here on the UI to show the decrypted price, to make sure that the encrypted price and the decrypted price that are, as I invoke the smart contract, it's being encrypted and decrypted correctly here, because I see here only the encrypted version, right? That's in the smart contract. The UI is not showing me the decrypted version. So you also needed to improve the UI to being able to show the decrypted values for the smart contract. On the previous version I created, I'm not sure if I was showing the price here and if it was showing the right price here. It says private pricing. So it doesn't. Another good feature that's working here on the UI, at least on this version of the UI, is I'm able to transfer the ticket to another account. So if I'm here on account 8, so if I go to another account, like account 7, these are all test accounts, right? And try to transfer the ticket. It failed. Why? Well, Rome wasn't built in a day, right? Let me see if in this UI I have the... Let me try to purchase a ticket here. Yeah. Well, there's too many corners to many things to improve on this UI, right? So not everything is working. Whenever something goes wrong, I can show you how we usually deal with that. Basically, we cope the error and ask Replit to fix it. Now it says the ticket was purchased. Maybe let's go to the smart contract to see if there was really an invocation. Well, yes. Well, looks like it's working. It's not perfect, right? Because it's invoking the smart contract. Sometimes not everything works the first time. I think both UIs still have some issues. Let's see if I have the tickets on it here. Well, it even shows my tickets here. Okay, the price, as you say, it's encrypted. I might try to transfer here to another person. Let me see if it works. Well, it says the transfer was successful. Let's see if the invocation. Yes, it really invoked a transfer from this address from my account, right? Account 8 to account 7. This is the address of account 7. So the transaction really executed. Well, the whole thing still have a few glitches, but for an hour work, having a whole D app developed is quite a feature.
It's impressive. The progress, right?
Yes, it's really impressive. Well, maybe in a month, this whole process runs flawless. and you are able to do everything in 30 minutes. But it's good that how the tools are progressing, and with some patience and some debugging, you are able to have a full DApp application. And whenever we have the COTI snap included, I think the UI integration would be really easier, because the clients would be simpler, because they could handle everything from MetaMask. They don't have to keep this server side wallets that make the process much more complex. And that's really all I have for you today. I will update the GitHub to include the Ethers client there.
It was great, Percival. I hope so that in a month an AI can complete this in 20 minutes or something like that. But so good, Percival. Great work. Great job.
Thanks, everyone.
Thank you.
Thanks, Percival.
Stay COTI.
Stay
Stay
COTI.
coding. Bye-bye.
Thank you. Stay COTI.